Hello, everyone. How is everyone doing today? Hopefully, everyone's doing good. I'm sorry if I cut some conversations. I know that I cut the one that I was in the table at, so I'm sorry for that. Today we're gonna have. Yeah, I'm sorry I cut the conversation with Peter. I'm sorry, Peter, but you can continue your conversations uh, once the once the workshops are over. Yes. So this is my honey badger jacket, which is the esports that we have at UTEP. You can get one if you join the organization and contribute with some time, and uh, we can work around try to get you some. But that's a mic question. But okay, so today we're gonna be having a special guest that is gonna join us for two workshops. His name is Hector Lugo, and he's gonna be joining us shortly. Today it's gonna be the workshop about project-based learning, and the next one, well, we'll let you know later on. If you saw the schedule, you know that it's what it is about. Yes, if you're part of the esports gaming, you can get a jacket. So make sure to follow us on Twitter, Instagram, and I think in Twitter you can find a link tree that is gonna take you to our Discord account, and then there you can join us and start going to the general meetings, which I believe is gonna happen next week or this week. We're still debating on that. So make sure to follow us on social media and keep up with the news. So today right now I'm gonna ask Hector Lugo to join me here so he can uh, start the presentation. What is the second workshop? How are we gonna fit the workshops into 1 hour? Well, the second workshop, as I was saying before, it's project-based learning, and no. The first workshop, it's only one workshop today. The next time Hector is gonna join us, I think it's March 22nd, and okay, I'm gonna spoil it. It's 3D printing, but that one's the workshop that's gonna be in 2-3 weeks from now. Because okay, so just to remind you, I know that this is every other week, but next week is still school, and then after that it's gonna be spring break. So we're not hosting any workshops on spring break, and then after that we're returning. So yeah. So Hector, may I hope that you're ready to present?
Yes, indeed, I am. Thank you so much, Fernando, for the introductions and for also sharing the spoilers alert. But thank you.
Yeah, I'm sorry. I spoiled it for everyone.
Yeah, no worries.
Really.
I'm used to it. Yeah, hopefully everyone gets to enjoy spring break for sure. So, hello everyone. I hope everyone is nice to see each one of you. Hopefully, as we continue through this workshop, I get to know a little bit about each one of you. And the most important thing is that you can actually get to have or enjoy this workshop. So as you can see today, we're going to cover project-based learning. This is for Techie Teach 2021, today, Monday. And as Fernando was mentioning, I am part of also, I collaborate with Create, STEMGrow, Learning Environments, and Gaia, the Makerspace, plus Honey Badgers, and I'm pretty sure there's other student organizations that I'm part of. So without further ado, let me start with this overview. On the meantime, if you have any questions or anything, you're more than welcome to ask them on the chat. I'll be reading them, and then I can definitely answer them. Then if there are any questions or anything, you are more than welcome to ask them. And I do believe, yes, this session is being recorded. Yvonne. So if there are any questions, I will be more than happy to continue, which is what we're going to cover today is a little bit of introduction. That means we're going to introduce each ourselves, or you get some chance to talk to a group of people. Hopefully you might get to know them and then chat, and then hopefully this could be a good way to start some collaborations or help each other out. Then what we're going to do is talk a little bit about what is Makerspace, then what is project-based learning, then at least an example. I'd like to give some examples, but we might run out of time, hopefully not. Then we'll get to do a little bit of activities, brainstorm, and I don't want to say it, but a small assignment if you want, or homework, but I always like to say a challenge for each one of you if you want to be part of it. There's always, whenever I ask for challenges or assignments or homeworks, there's always prizes. So hopefully that might encourage you to do them, to do it. So without further ado, let's start with introductions. As you can see right over there, that's me. When I used to have hair, not anymore, but right now it's cold, so that's why I'm wearing the beanie right now. As you can see, I was born in Mexico. I have been here 12 years, almost 12 years in El Paso. I started my bachelor's in electrical engineering in 2009. Then I continue working as a part-time student at Learning Environments UTEP. That's when I was a student. Then due to all the good experience and opportunities, I was able to be as a full-time. Then I was able to graduate my master's in electrical engineering, Master's of Science in 2017. But that's as in terms of academic curriculum. But if you were to know me, then you would get to see that I like to craft. I also like to destroy some things, see what's actually inside as in terms of electronic components. That's what I was meaning as in terms of destroying. Then I also like to redesign or create new things. I have a makerspace philosophy. You will get to see it later on. And then also like to support and encourage people to find their passion and be able to succeed. So as you can see, there are some pictures about me. There are some things that I like to do and my passions. That's something that we're going to cover later on in this presentation. So just keep that in mind, passions. So what we're going to do today is a little bit to break the ice. I did notice that there are a lot of people right now. So what I'm going to ask each kindly of you is to at least get into a table, at least a table be part of 5 people. So that way you can actually get to talk with each one of you. We're going to have 10 minutes to talk to each other. And then what I would like to do is think about, introduce yourself, write your names, and then talk about 2 hobbies that you like to do and 2 passions that you like. So without further ado, let me just put the timer so that way everyone gets to talk for 10 minutes. Then once we're done after 10 minutes, what I'm gonna do is we're gonna go back to this presentation. So let me stop this recording real quick. Any questions? If there's no questions, then I'm gonna cancel this presentation. And then we're gonna start the 10 minutes introductions for each one of you. What I'm gonna ask is, with the table that you were talking, you can please establish a point of contact. That means that at least share your email. We would like to see, if possible, 3 people. So the way you can get to know or get to talk with at least 3 colleagues within this program. What I always tell to my students, this is something that I do with my students that I get to teach, professional conduct. So that way, please be respectful. Then you can also share your phone number if you feel comfortable. And then so that way you can talk about related topics, or if you have any questions or anything, you can definitely do so. And then if you want to share your social media too, so that way everyone can follow each other, you're more than welcome to as well. So I hope we'll do this as a reminder once we go into the next activity. So the next things that I want to cover, it's theory, or I guess definitions. So I hope that everyone will like, at the end, might know a little bit more about Makerspace. So just out of curiosity, does anyone know about Makerspace? You can raise your hand, or you can just put a thumbs up on the chat just to make sure, just to see if anyone is familiar with Makerspace. Okay, I see a couple of no's and yes. Maker vegetable garden. It's relative. We're currently working on aquaponics, so there's for sure some vegetables that they're going to be. In other words, they're going to grow some. They're going to have some fish, and then they're going to grow some vegetables on those aquaponics. So, so to continue with the presentation, I'd like to show this 2 quotes, which is from Nikola Tesla. When I get an idea, I start at once building it up in my imagination. I change the construction, make improvements, and operate the device on my mind. It sounds a little bit way too technical or way too advanced, but basically, I like it because I like to think that everyone always have ideas, and those ideas come from each other, like from your personal mind. In other words, maybe you want to improve yourself, or maybe you care about some other people and you start getting some ideas or start thinking of how you can make someone else's life better, or even yourself, or even the community, or maybe someone that you haven't known yet. So with those ideas, you actually start with the imagination, and then you start building things in your mind. Then hopefully, once you're done with this presentation, maybe you can put them on a piece of paper. And then once you put them on something tangible, which is a piece of paper, then you can actually get to do something physical and then make the world better. That's why I have my makerspace philosophy, which is hopefully a lot of people would like to care and create things to improve the world. Then the next quote is, ideas pop up wherever they please. Inventors come from every corner of life. I like that one because that means that each one of you are inventors, and each one of you can definitely make something and could actually make the world better. So Pagan Kennedy, she's actually she writes magazines, so you can definitely do either STEM or STEAM. So Makerspace, it's a place where you can definitely, it's a collaborative workspace, as you can see right over here. People right here were doing hackathons, so they actually stay like for the whole weekend, 24 for the whole weekend, 24 hours each day, and they were actually competing for a project where they actually had to do a contest. Then, as you can see right here, this is Carla Ayala. She was actually teaching how to do 3D design using Tinkercad. You can see it ranges from all ages. We also have right here a tour where people were 3D scanning. So as you can see, it's always about people and technology, and probably also non-technology, as you can see on this side, where they are painting. So then go to the next slide. It's a place where you can make, learn, explore, and share. So as you can see on this side, they were 3D scanning a snake. So that way they can actually do some research, and they actually get to test it out in Honduras. So it has been a project for almost 2 years, but they actually were able to be recognized, and they're writing an article about it. So kudos for them. Then, as you can see, these are part-time students helping and collaborating with other students doing their research. As you can see right here, this was another class, another course where students, as intro to freshman students, they were able to 3D design their own personal unique item. Then they get to test it out using some weights, some counterweights, so that way the model could actually sink or float. It all depends on the research. Then there has been other collaborations, for example, from nursing, where they were able to 3D print a bone marrow. Then, as always, outreach, so that way people can get to see the 3D printers. Then it's open to anyone. That means student organizations, that means community, as in terms of outreach. It's open to any age, where people were also doing patents, and as also people wanting to learn what new technology is out there. So as you know, our makerspace, it's open to anyone. So that means that anyone's more than welcome to use it. Anyone's more than welcome to ask for any questions, and we can definitely help them out or teach them or help them in their personal or class projects. So right here on the makerspace, there could be high-end tools. As you can see, we have a couple of tools right over here. So we have the CNC. Then we also have right here students where they were doing electronics with Arduinos. Then we also have right here where you can actually get to 3D print PCBs, printed circuit boards. So that means any electronic, you can definitely create them right over here at the makerspace. And the last one but not least, 3D printers. So these are the high-end tools, high-end tech tools, we also have a saw stop. That means a saw where you can actually do wood chop, and then we also have laser engravers. So we do have other equipment, but it wouldn't fit right over here. But we also have non-tech tools, and this is just partially. For example, it might look simple, but it's one of the most critical things is paper and pen. And the reason being is because that's where you actually get to um, be able to, in other words, write it or be able to transcend from your ideas in your mind all the way to paper. That's the most critical thing, because that's where you are actually from an abstract or non-tangible thing, which is your mind, your thought, your process, into a paper where it will start to be a reality. So that's one of the most critical things. Then, so you can see non-tech tools, you can definitely find cardboard. Who doesn't buy things from Amazon? I like to think that a lot of people get to do that. So there's plenty of cardboard. If not, then you can definitely go maybe when you're going for groceries or something like that. If you were to go Walmart or Albertsons or whichever place, you can definitely ask for some cardboard. And I'm pretty sure they're more than likely to give you some cardboard for free. Then some scissors, glues, and pen, you can definitely do so. So as you can see, you have right here, a person wanted like a pony. So they were able to sketch it up right here on cardboard. And then at the end, they actually got to build it at the end. So that's what I want. Hopefully there's something that I would like to mention, or I would like for everyone to remember, at least by the end of this presentation, is that you can definitely build anything, and you can definitely get to do it with low tech, low fidelity. That means that you can definitely get to do anything from scratch, and you can definitely do it on the cardboard. Then from there, you can go into very specific tools. So this is a long definition about makerspace, but I don't want to say it because it's way too long. Basically, a makerspace is a collaborative workspace where people get to make, learn, explore, and share. It's open to anyone. Then high-end, you can use high-end tech tools or non-tech tech tools at all. And then from there, you get to specialize, either something very technical as in terms of equipment or tools, or maybe a software. Then what I want to talk about the makerspace is that we are in the 21st century. That means that the skills or what the companies are asking is they are changing a little bit. That means that they're asking for critical thinking, that where creativity is really critical, collaboration, communication, information and scientific literacy, digital technology, design literacy. But the most important thing is self-direction, flexibility, and resilience. And I like to think that with using PBL, you can definitely get to enhance this skill, which is self-direction, flexibility, and resilience. That means that people are also looking for STEM and STEAM skills and careers that are tangible and approachable. And then when you're using a lot of PBL and makerspace, there is a stage, that means a set of steps where you generate the ideas, then you actually start doing some problem solving, then you get to use some digital design processes, so that way you can actually get to have something physical or fabricated. Then it also provides a visual demonstration of abstract processes, algorithms, complex math concepts, and science lessons. So, like I mentioned, this is a theory, and it's going to take a little bit more of minutes, so just bear with me a little bit more. We're going to have more activities. So we have also, what is invention versus innovation? So invention, as you can see, is when you translate a thought into a thing. Usually involves creating a prototype that lets you test your concept and demonstrate that it works. Versus when it comes to innovation, is the act of working all obstacles and problems as you continue through the creative ideas into business. There was a typo, sorry about that. So what we get to see nowadays with the companies is that they're changing from mass production, that means mass produce, into now what is customized production. So everything that is going now, it's more unique, it's more intrinsic, and it's actually more customized to each individual or each user. So that's what we're starting to see as in terms of business. That's why when it comes to 3D printing and other more accessible and affordable tools, you would get to see that you can actually create unique things. There are different kinds of inventors, and this is where I'm going to ask for everyone to please uh, listen a little bit carefully, because when it comes to inventors, I like to think that there are always different paths. So that means there are different kinds. So hopefully you might identify with at least one, where, for example, you have inspiration, where maybe you like to think, maybe ideas arrive like angels, maybe you're dreaming about it, or and then you have a little bit of a I would like to say like a moment of truth, where you can actually come up with something where you can actually create new things, or you amplify them or make them better. Then there's also discovery, where you can actually get to stumble across a surprise. Accidents turns into inventions. I can name a couple of them, or probably you can already know some of them, where it might come up out of a mistake or something like that, and then something is it's new has been invented. So that means discover the power of our imaginations only when we feel desperate sometimes, either for yourselves or for someone that you care the most. It could be one of those ones. Then we also can have other kinds of inventors, where there is prophecy or futuristic thinking. That's when it comes to science fiction. So if you like to read a lot, then this is where probably you might be getting some ideas, like writers, like creative writing, when they do this science fiction, it motivates other people to make them into reality. So you can definitely be those kinds of people. There's also cross pollinators. That means that people would connect unusual ideas where they unite a problem and solution, or maybe it is also just collaborating with other people, and then at the end you actually get to have something unique and new. And then there's also empowerment. That means it takes enormous courage to claim a problem. So connecting unusual ideas and then unite the problem and a solution. So this one is more about asking the community, so that way you get to see what the real issue is as in terms of society, and then come up with ask for feedback, or look for new ideas, or what's really happening as the real reason, then come up with new things. So we're going to go to the first part. So as you can see, we have a number from 1 to all the way to 37. So if you can just write your name and the skills. So for example, for this question, I'm just writing which 21st century skills would you like to teach to your students? Take some time to think about it and reflect on it. So the way I'm not put in a rush. We have 8 minutes. I think it's plenty of time to answer these two questions. So if you can do or follow the format, just write your name, then answer the two questions. For question number 2, just keep scrolling down. So that way you can get to see part 1B. Alrighty then. Well, thank you so much for writing. I will definitely. So right now, feel free to read them if you want. It is critical to read each response and to take into consideration. We can definitely cover them some other point time as well. So thank you so much for sharing. This actually gets to see, it gives us insight to see how each professor, what they really care about, what they consider critical, what they would like to see for the students, because that's what matters the most at the end. Is how can we prepare our students for what's coming right now once they continue their education until they can accomplish their dreams. So thank you so much. Take your time to write if you continue, if you want to. But we're going to continue with the presentation because we only have less than 30 minutes right now. So to continue on, to further on, there are some tips as in terms of makerspace. And what I would like to say is that it takes time to crack a difficult problem. Some people like to think of like 24/7, or sometimes people like to just take your time, observe, imagine, think about what is possible, what you can do, because sometimes it's hard, or you might have a process or an idea that you can definitely make it, but once you start making it physically, then you're starting to notice that there are some challenges or some constraints. I'm not saying that it's impossible, but as you continue through your project, you might get to notice that it might take some time. But at the end, some of the things that I always like to mention is don't think about the prototype. And by that, I mean, don't think about aesthetics. Don't think that that's the final product. There's always room for improvement, and you can definitely make it better as you continue. It doesn't mean that you only have one try and you're done with that. You can definitely continue working on it. Then there's also micro creativity. You always think about collaborations, and that is perfectly awesome and does help, especially when we're stuck. But there's also inventions at the level of the individual. So never doubt on yourself. That's what I really wanted to say. Never doubt on your creativity. You never put yourself low. You can definitely always find and do the best for yourself and for people. And as in terms of problem finding, sometimes it is hard to know what works best as in terms of hidden problems. So take your time to really know what's the real problem, or you might find out other problems as you continue trying to solve something. So think of short term, long term. Sometimes frustration produces creativity inside. So whatever emotions you're going through, just let them sink into your body, into your mind, and then try to just get to identify your emotions that you're going through, trying to brainstorm or think on a better positive way that you definitely take your time and you will find a solution, or people can definitely help you out. There are leaders, in other words, that they're lead users where they can be as an example or they can help you out. So it's never bad to ask for help. People are always there willing to help you out. And then if you want to understand the problem, just like the cross, like the empowerment, as the community, so that way you can actually get to really know what the problem is. So this is our just some tips. You don't have to go by those ones or follow the rules or follow the book. And then some things that are nice to be in consideration now that we're in the 21st century is that things are better nowadays. So if you were to think about it, when I say those words better, it's because when it comes to the various invention are falling as never before. So what I try to say with that is that now we have a lot of accessibility when it comes to laptops, or you can use your own phone or access to use someone else's computer or tablet, and you can actually get to do your own research and develop tools way much easier than, let's say, I still remember when I was a kid, that was like 20 years ago. I would actually have to go physically get the dictionary and look for a specific word, where now you can definitely just grab your phone, you can Google it, and there you go, you have the definition. So there are so many tools that can definitely help us out, and they can definitely help you out exponentially. Then there's also the good thing is that you can consult. That means that you would consult on a community 20 years ago, you would have to walk, and probably it'll be very limited or close group as in terms of your school, your neighbors, your family, and maybe the people that you might get to encounter on random basis. But now with the internet, you can actually get to access millions of research papers, exchange ideas, there are podcasts, there are groups, there's servers, there's the possibilities are limitless. There's tons of things. Then why not? You can definitely raise some money. You can probably start your own company, and then you can actually get to have some feedback. And the cool thing is that you don't actually, when it comes to getting this feedback, you're getting it for free. And it's people that are really, and the people that are really interested as in terms of your product, they would actually tell you the real feedback, and then you can actually get to iterate or modify your product as you continue. So there are so many good things. And then last but not least, you can exchange digital files. That means that you can communicate directly with people around the world, and you can also get to have like real-time feedback versus if you were to send it like some people, like when it comes to fabrication, people would send files to be printed in China or some other places where it's a little bit cheaper, and then you would have to wait like probably months to actually get the final part piece. And I'm talking as in terms of 3D printing. Then it's a lot of resources as in terms of time. You might save a little bit of money, but it would definitely consume other things. It would put into hold some other processes. So versus right now, you can actually just change the files. People can actually get to look at them. You can get some real-time feedback, and you can actually get to reprint some things. So those are some things. Now that we finish Makerspace, if you have any questions as in terms of Makerspace or anything, please ask them. So that way we can, I can do my best to answer them. So if there are no questions, then I would definitely go into project-based learning. So any questions as in terms of Makerspace? Let me check. Alrighty then. I guess we don't have any questions. I don't know if that's a good thing. So as in terms of PBL, I would like to talk about some reference frameworks. I'm pretty sure that all of you are familiar or know them by heart. So for example, Bloom's taxonomy, where you have the pillar where you remember, understand, apply, analyze, evaluate, and create. And what I would like to say is that with PBL, hopefully we can get to see that we actually get to cover partially, almost if possible, all of them, as in terms of Bloom's taxonomy, where at the end we will be creating. So that means that the student or anyone who would do the PBL will go through this process where they would go through remember, they would actually understand it, they would apply it, then they will analyze, as people were talking about critical thinking, they would evaluate, and then at the end they would actually create it. There are other models, like for example, substitution, augmentation, modification, and redefinition, which is the SIMR model. It's a little bit similar to Bloom's taxonomy as well, but this one it's more about technology based, but the one that I want to cover about is more PBL. So PBL, as I have mentioned, is more about project-based learning. So that means in simplified version, it's learning through projects, which is a method of structuring curriculum around projects. So there is something that I would like to talk, which is what's the difference between projects and PBL, project-based learning. It's almost the same, right? Well, the thing is that when it comes to projects, it's more, they tend to focus more about the product that comes at the end. So in other words, that's there's a lot of cases where people really care more about the students just presenting what they actually the instructor ended up asking to do, versus when it comes to project-based learning, it's more about the process, and that's where the real difference is. So in order to do more PBL, what I would like to always emphasize is more about the desired learning objectives that should help dictate the products and artifacts within the project. So in other words, the most important thing is see what you would like the students to have as a learning objectives. Then you can further on and expand on in terms of the products and the project itself. So looking first at the learning objectives and academic standards, then you actually get to brainstorm the project ideas and components of that project. That means the audience, the purpose, the durations, what kind of project, the complexity, and those kinds of things. So it's always more about the learning objectives, what really matters. And as I was mentioned, this could be useful as in terms of in the course of completing the project and the desired learning outcomes and objectives. So to talk about this, I guess in a better and simpler form, apologies for this, it might not look better, but let me see if I can do it right over here. I'll be more happy to read it, but basically it tells doing projects. So basically, when it comes to doing projects, the teacher has knowledge. Then once the teacher has knowledge in something specific, then the teacher gives direction to the students. In other words, the teacher keeps telling what to do to the students. Then the students will follow the directions. Once the students follow the directions, then the students will learn the facts by following the directions. So then at the end, the students get to present and we'll present the facts, and that's how it is. So if we were to look almost on the Bloom's taxonomy, then probably at the end they get to present. So maybe they would actually do remember, then understand, and maybe they would actually get to go to apply. So because they would use new information and new citations, or all the way up to here, hopefully. So as you can see, it's halfway when it comes to Bloom taxonomy. But if we were to go now into project-based learning, there's a small difference. The teacher only asks a question. It doesn't have to be only just one, but ask a question. But that question has to be very leading or pathway. In other words, it has to have a strong direction where you want to lead them. That means the desired learning objectives that you want the students to go through. So once you ask a question, then the students devise their own directions to take the solve the problem. In other words, the students are going to find different pathways, allow them to look for different kinds of possibilities, let them test it out and see if it works. That's where it comes to really the real world application. Then once the students start looking for their own pathways or directions that they want to go, let's say if this is only just a individual PBL, then allow them to do so. We'll definitely talk a little bit about group PBLs later on. But basically right here we have the students test and revise their own directions, see if it's feasible, see if it's tangible, and then the students learn information and develop skills. Then at the end, the students apply their own knowledge, skills to solve a real world problem, then they are ready to answer more questions. So basically, they were able to go at least until evaluate or create, if they were able to create their own prototypes. So as you can see, it goes all the way to the top versus just doing projects. It could actually just go all the way to apply, maybe. So that's all difference. So what I want to cover as in terms of how it could benefit the PBLs and how maybe a suggestion as in terms that of this way, this method could help you out. Think of it like steps. And it only consists 4 steps, but the most critical ones would be all the way to 3. And why do I say 3? Well, the thing is that when it comes to prototyping or to create the tangible or the physical way to test out the project or the desired outcomes that you want to teach. So prototyping is solving problems by creating a physical or digital objects. So as you can see on this slide right over here, as in terms of prototyping, the first phase is really just sketches. That means paper, drawing. Then we also have some other materials that probably they might look familiar to you. So for example, this one is just straws, then some paper, and then just some tape. So as you can see, it's not very high tech. It doesn't have a lot of resources. It doesn't cost too much. And probably this kinds of tools or materials, you might be able to find them in a household. Maybe they're right next to you, especially right now, especially if you're a teacher. I'm pretty sure you might be able to have some tape right there, or maybe some straws, or maybe some cardboard, maybe some pens, maybe something that you can definitely get to do with low tech. And even myself, I might be able to find some right here, some materials. I purchased some things from Amazon. So the cardboard from Amazon itself, I can definitely start prototyping and crafting and creating things. So as you can see, the first phase is just sketching. Then the next phase is to really start from low, medium to high. So in other words, if you were to think as a person, we always start by crawling. We never start running. So we start by crawling, and then we walk, and then we run. So I like to think that this is the same process, which is we start with low, medium, and then high. Where the low, as you can see, it's scissors, tape, glue, and hand tools. So that means low fidelity. It's practical. It can actually get to prove the concept, and it allows you for creativity, problem solving. So that way you can actually get to see if you're on the right path, on the right direction. And you can probably get to do this all the way to the end, where when it comes to medium or high fidelity, it's basically just transitioning from cardboard, from simple resources into high-end resources. That means using laser cutters, using 3D printers, hand tools, power tools, drill press, saw stop, all those kinds of things that would cost a lot of money, then those ones are considered as in terms of medium or high, as in terms of resources. So this is where I would like to ask that hopefully within the next activity that we're going to do, you can think of PBL, or you can think of a project that maybe you would like to ask to your students, and keep that in mind, that if you can ask them to go on a low fidelity. So let me just go to the next slide. This is really critical, so if you have any questions as in terms of this slide, please let me know. So again, when it comes to prototyping, think about low fidelity. That means low resources that you can probably find, either very accessible, and probably can find them on your household. And then once you actually get to prove it correctly, then you can transition into medium or high fidelity. So as an example, let's say this is something that I did last semester with the students, where I asked the students, me as a teacher or as an instructor, my desired learning objectives were how to sketch a design on paper. So in other words, I would like the students to have the experience to sketch a design on a piece of paper. So that way, because sometimes I get to see that students, they are very smart and they actually would like to go to the final product, or they like to jump and skip other things right away. So that's why I was asking the students to sketch, because I want them to go through the crawling process, which is first think about the design, write it on paper, so that way you can take some time to think about it. Then the next thing that I asked them was to prototype using low fidelity, where I asked them to use cardboard or glue or strings or paper, anything that they could find at home. They can definitely use it to create a small prototype. Then at the end, I wanted them to come up with a final 3D design and print it, because the most critical thing was to learn a new software. So then they can actually get to print it out, so the way they learn more about the technical stuff. So the next question is, how can it be simplified into a question? I'm going to talk that on the next slide, but that's the 3 things that I want you to cover. Think about these 3 questions. What are the desired learning objectives? How can it be simplified into a question? And then the next one, I always like to mention it, because what else can the students learn aside that can complement the project? In other words, what else can the students learn by applying this by going through this desired learning objectives? So for example, I always like to mention, like, as I have previously asked you, what are your passions? What are your hobbies? That's when you actually get to be more unique and specialized, and you get to have more creativity and a little bit more, has more meaning as in terms of each project. So for example, I have a passion, and I have always been wanting to learn a little bit more about planting or gardening, because lately, not lately, but like 3 years or 2 years ago, my plants would die because I always forgot to do things. So maybe by this, it would actually be more meaningful and more intrinsic, and I would actually get to do more unique and a little bit different, a better project. So my question that I asked to the students were to create a personalized animal planter. And why did I ask that question? Well, the reason being is because when it's something personalized, something that it's unique to your, something that you created, something that you did by yourself, then it actually has more meaning, it has more value, and you would actually do more on this project. So as you can see, there were some sketches. They're not beautiful. I don't draw very beautiful. Then, as you can see, there's some low fidelity. It's not a very nice llama, but I like llamas from the Emperor's New Group or Emperor's Group, so that's why. And then from there, I went into 3D design, and then I was able to 3D print my planter. So that's what the students actually ended up doing as well. And they started with the sketches, they did the low fidelity, then they actually did their 3D design, and then they 3D printed it. So we're going to go to the next activity, which is probably in 5 minutes, less than 5 minutes. And that one will definitely take some time. So real quick, right over here, this picture, it always it always gives me some meaning that it is a beautiful beach, right? out right over there with the breeze and the sun and everything, especially after the cold weather that we just endured for 2 weeks ago. But the purpose of this picture is more about the stones. So as you can see, it is balanced, where you have only one rock with the exact amount of weight to be equal to this couple of rocks. So what I wanted to mention with this slide is quantity versus quality. So there must be a balance. So what I'm gonna do real quick right over here, I'm gonna go into Q&A. Then I'm just gonna put 2 words, which is quantity. Then the next one is gonna be quality. Then what I want you to write is, awesome, thank you so much for helping me out. If you can get to both, which one do you think it's important, quality or quantity? Okay, so I do see 5 answering. So to answer the poll, remember, just look on your right side where it says Q&A. Then that's where you can vote. Just click on whichever you think it's the most important one. So I do see that a lot of people do really care about quality. And that's nice. That's interesting. That's good. All right. I do see that for sure quality, I think it's gonna win as in terms of quantity. But if I may ask, or if I might say, the poll, Peter, it's gonna be, as you can see, the presentation on the right side, where you see chat, participants, and Q&A. Click on Q&A. So Claudia, to answer your question, what's the difference between 3D design to 3D print? The difference is that on 3D design, that's where you are using the software. That means you have the STL file. That's where you actually get to design it. And then that's where you actually get to modify or edit it if it needs to be. Versus when it comes to 3D printed, that's where you actually have the physical model. I hope that answers your question, Claudia. So I do see that there's a lot of quality wins as in terms of quantity. So if I may ask, hopefully this doesn't bring some conversations or some intense conversations, but I think that your answer could also be, it depends, right? Even though I didn't ask you for yes or no, but it could also be, it depends. And the thing is that, or the reason why I say it depends on exactly what we're talking about and in what context. For example, like, let's say that you have 50 tasting bananas, and then versus 1 banana that tastes better than any other banana you had before. Well, that is awesome. Like, that's where you probably can say, all right, that is perfectly fine if you choose quantity, versus other people who like, you know what, I would like to taste the best banana ever in my whole life. Like, I don't care about the other 49 bananas. I prefer that one. That is perfectly fine. But it also comes to the situation that we are. Like, for example, like just like I mentioned, below there it says, if you're stranded on the desert, on a desert island, then it really doesn't matter. I like to think that it really doesn't matter what the banana tastes like. As in terms of survival skills, I like to think that people would choose more quantity versus quality. But maybe some other people, they don't like bananas at all. So what I would like to say is just keep a mindset that it's not always just quality versus quantity. It all depends to how the situation or the environment or the project itself it is. And I like to think, just like I mentioned with PBL, it's more about the process, not the final product. So hopefully that doesn't break too much conversation. Then, as I mentioned, I was going to talk about group PBL. So with group PBL, we have right here, you can assign it in teams. This is something that I did as in terms of online hybrid, which is partial students were doing face-to-face and partial students were doing online. So the students will take the roles as in terms of leader, scientist, data analyst, and engineer, where they actually get to do some roles, specific roles, or extra roles in some sense, because each one of them would help with the project. And then they have some extra roles, such as assist and lead, or some other people would do the research and report, and some other people would do the design process and make sure that the outcomes are realistic. So just to give you some examples about when it comes to PBL. So before we run out of time, this is going to be the next activity, which is brainstorm. So before we conclude this session, let me go through the whole presentation, then we'll end with this brainstorm activity. So this brainstorm activity, even though it's set right here to 15 minutes, probably we're going to have to shorten it by half at least. So what I would like to ask, and take your time, it doesn't have to be right now. Think about it for the next couple of days. Think about your teacher desired learning objectives. It can be 2 or 3. It doesn't have to be a list. So think about the simplified question that you would like to ask to your students. A directive, a guided question that could go to where you want the students to cover the learning objectives. And how can it be complemented? Remember, when I say how can it be complemented, think about your passions. Think of something that you would like the students to learn. Like, for example, critical, the 21st century skills that you think about. Or the other question that I asked you, what do you think, let me see right over here. Which path does it resonate to you the most? Like, for example, what kind of thinking process or inventive process you would like the students to go on that adventure, or probably you can guide them in that way. So those are the brainstorming activity that I would like to ask you. So you can brainstorm it on a piece of paper. You can talk with your people on the table, and then you can write it on the Google document as an activity. So we'll do that as at the end. And then the last thing that I want to talk about, it's more, I don't like the word assignment and homework. I like to think it's more like a challenge, but not a challenge of something hard. It's just something that you could have some fun with, or you might have a good activity with your family. And the reason why I say family is because nowadays that we're spending more time with family, probably it could be as a nice activity with everyone. So the activity or the assignment is these 2 things, which is what would you like to do this semester within Techie Teach using PBO or 3D design? This would actually help me out to do something unique and interesting for the next session, which is on March 22nd, if I'm not mistaken. And then the detail, the better. And then this is the challenge, which is, like I mentioned, this is something that I did last semester, which is tensegrity. When it comes to tensegrity, there's a research. So basically, it's more about the tension of on the strings right over here, as you can see. You might not be able to look at them, but there are some strings right here that it looks like the object is floating. However, like as you see, the top part, it's floating and it's not tied into it's not glued into something, but due to tension of the strings right over here, it really works as an object that could actually handle weight. So the question or the activity or the challenge is to design a tensegrity object using low fidelity materials. Then if you want to earn some extra points, and what I mean by extra points is prizes, that I'll definitely cover that on March 22nd. If we can withhold an empty cup for March 22nd, that's when we will have the next session. If you get to showcase it, then you will definitely earn the reward of having a prize. So again, you only had to design a tensegrity object. You had to use low fidelity materials, and if you want to earn, I'll leave it to that as a challenge. Don't put a keg, that's way too hard, but it can be a plastic cup or it could be any kind of cup. Remember, it's more about, well, what I would like to say, or what I would like to mention, it's more about the process. It's not about the challenge of, it doesn't have to be a glass cup, whatever works best for you. So that's a challenge. I would definitely post this presentation later on to Carla and Fernando, so that way they can post it on the Google Drive. And also, there's a PDF file So the PDF file, it'll tell you like the constraints and everything if you want to look at it on the perspective of the students. But here's an example of what a student actually got to do. So they prototype it right here, as you can see in cardboard. But then at the end, what they actually did is a video right over here. So as you can see, they transition from cardboard now into sticks, wood sticks. Then that comes to you, Claudia. There's no, like when it comes to me, there's no limitation. It's whatever you think can be as a low material, low fidelity materials. It could be anything, cardboard, it could be paper, it could be whatever you choose. What's available to you, just like Mike mentioned you. So as you can see, that was a project that a student was able to do at the end, where she actually put this object right over here on top of it, and it didn't fall due to the tension. So without further ado, I'm going to cancel this presentation. I know that we did run a little bit about time, so I do apologize. But if you would like to write the brainstorm later on, the PBL, and then if you can help us out by writing it on the Google document, it would definitely benefit, I'd like to think, everyone, because this link will be shared to anyone. So the way each one of you can contribute, and we can provide some ideas to each other. So without further ado, this concludes my presentation. I hope everyone had a good time. And then if you have any other questions, please let us know.
Hector, it was a pleasure having you. This topic is super interesting, and we know you love it. That's why you an hour and a half is short to talk about this topic. But yeah, this is a great topic. It's highly interesting, and it's evolving every day with the technology. Everything is moving forward. So yeah, and now I understand that an hour and a half it's gonna be super short to express everything that you can do with these sort of activities and mindset. So we're gonna be uploading the presentation shortly, and as well as the video, we're gonna upload that one next week. Make sure to follow us on YouTube and our social media, and absolutely we will upload the Google Docs so you can answer and do that activity. So that's something that we can do, Hector.
Yeah, definitely do so.
Thank you so much for being here today. I know that if you have any questions, as we were saying for him, email us, and we can refer your questions to Hector. And I'm pretty sure I'm talking for him, but I'm pretty sure he's super happy to answer them.
Yeah. Then to answer your questions, Peter, those are really good questions. I will definitely answer them and post them on Google Document. Then as in terms of the makerspace, we do have a makerspace at UTEP, and anyone is more than welcome to use it. You can always send us an email, and then we will do our best to help you out. That comes as in terms of learning the software or learning anything or creating a project, guidance, whatever you need, we're always there to help you out. The brainstorming is individual, but if you want to do it by groups, you can definitely do so. But I would prefer individual, so that way we have more examples.
Yes, and remember, for your homework, it's gonna be a picture of your PBL, so that we can see what you worked with. It doesn't necessarily have to be exactly what Hector showed, but it could be something like that if you want to participate for the contest and see what Hector has as a prize for next time for whoever wins.
Oh yeah. So the PBL, it's a homework. Remember, it's more about the desired learning objectives that you would like to give to your students, the simplified question, and how can it be implemented, complemented, my bad. And then as in terms of the price and everything, you had to show a low fidelity at integrity object.
Okay, it was my mistake. The homework is that it has to be like that. I'm sorry. That was my mistake. They're correct.
It's all good. No worries.
Okay, so thank you so much for being here. We're sorry that we're 3 minutes over, but see you and once again, you can come back next week, and we're gonna be here to answer questions, and if you want to get to know your classmates, we could call it like that. You're super welcome to be here and ask questions or get to know us. And so yeah, we're gonna be here next week at the same time, and we will see you again with another workshop on the 22nd of March. Bye everyone. Have a good night. Thanks for joining us. And I'm really happy that I got to know a few of you. But I'll be moving around trying to get to know everyone. Good evening. Have a good night.
Good evening, and then I guess we'll cancel this presentation, and then if you have any other questions at the end, we can definitely do so. We can stay there for a couple of minutes.
Absolutely. Bye.